So yeah, like I said, I'll be talking about blind SQL injections. So a little bit about me. I'm a penetration tester at Booz Allen Hamilton. I have a few certifications. Most important for this talk would be considered the Offensive Security Web Expert. I also have several web application CVEs from blind SQL injections to WordPress plugins. And I'm really passionate about web application and red teaming. So what are blind SQL injections exactly? Well, it's a form of SQL injection that won't return actual information from the database. And oftentimes, SQL errors will be disabled, leading to SQL injections and blind SQL injections specifically being more difficult. So since we won't be able to actually return information, such as when you use a union statement, we're going to have to ask the database yes and no questions. So there are two main forms of blind SQL injection. The first form is content-based, which essentially means that the website will show different behavior when you insert the SQL injection. You may be thinking, what exactly is this different behavior? Well, it could be a huge variety of things. It could be a 500 error code. The content length could be different. There could be verbose SQL errors. It could really be a lot of different things, and you're going to have to observe the response to see if it's giving a different anything different when you insert your SQL injection. The second form is a time-based SQL injection. So you won't be getting any different responses from the website, but you'll be able to insert sleep statements, and these will work consistently. And you're going to want to be very aware of false positives. You're going to want to be aware of false positives just because when you're using time-based SQL injections and you're trying to mess with the database, the server may take longer to respond. So you may think, oh, it's sleeping for 10 seconds, but really the server is just slow to respond. So to find an SQL injection, you're going to want to find specifically a blind SQL injection, you're going to want to test it similar to how you test a normal SQL injection using a single quote. And then once you insert the single quote, start by looking for differences between the normal request and when you insert the single quote. You can use tools like burp compare or some other tool to really dive deep and see if you can find actual differences in the response. And then if you do think you find a difference, and then you can insert the double quote. And if you insert two single quotes and the SQL Um, and so if you can observe the difference between two single quotes compared to one single quote, two single quotes should not error out the application or cause an SQL injection, whereas one single quote might. And you're going to want to use automated tools if possible, such as SQL Map, Burp Scanner, Acunetics, anything to help with your SQL injection discovery and exploitation. So looking specifically at content-based, these are some of the errors you may find. You may find that when you insert your SQL injection, you receive such as an internal server error for 500. You may receive a different content length. You may receive the MySQL fetch array error, or you may even find a completely different behavior when you insert an injection such as a 302 found. As for time-based, you can use a tool such as Burp to actually see the exact amount of time between responses. So here you see there's 27 milliseconds and 30,000 milliseconds, indicating like 30-second sleep. So you're going to want to do it multiple times and use different sleep periods. So go like 10, 15, 20, and make sure it hits it every time before you actually start exploiting, as you want to make sure that the server is just not slow to respond. So looking at this in Java source code, here we have a string called query, and it has an SQL statement with the select account balances from user data. And then at the end, we have a get parameter for customer name. And we pass this entire statement straight to the database with no filtering at all, which is not good. So here we can inject anything we want into the get parameter. We don't even have to really use a single quote because the get parameter doesn't appear to even be in single quotes. So this is not, so if you're looking through Java source code, this would definitely be vulnerable. So if we wanted to fix this, to start, you want to pass in with a question mark into the Java source code. Here we see that the string query at the end, instead of passing the get parameter directly in, we're going to pass it in safely. So that's how you would pass an SQL get parameter safely in Java. As for .NET, this is another, as you can see, there's going to be a common trend here. We're just passing in the variables with a login username and login password, again, with just the pluses, which is going to be vulnerable to SQL injection simply because we have no filtering happening and we're passing these statements directly in. So .NET is a little different. It's not as intuitive as Java. So for sanitization, you have two main options. You can either use the string, you can either replace it with every time you see a single quote, you replace it with another single quote, or you can use parameterization using the SQL parameter collection on get parameters. And you'll probably also want to use it on post parameters if you have like a login prompt. So for PHP, this is a CVE discovered by me and Sam Ferguson, also known as Affine Security. He'll be doing a talk, I believe, on day 2. So you'll definitely want to check him out. Super amazing person. But this is a CVE that we discovered through PHP source code. So to start, we have a MySQL query that selects just a select star from, and then we pass it in to the MySQL fetch array, and we pass the entire SQL statement in, and we see there is a post parameter called pin code that is passed through the .trim. Again, we see that the post parameter is passed directly through with no filtering happening at all. So for all of source code, you can tell really that you're going to, if you don't see filtering, it's pretty obvious. You don't want to pass the post get whatever kind of parameters directly in with user input. You're always going to want to use some form of filtering. So if you don't see filtering, or you see improper filtering, such as here, where trim simply removes white spaces, but it's not even used properly, you're going to see that it is vulnerable to SQL injections if the parameter is just thrown in with no sanitization. So fixing this, I fixed this myself with one very simple thing. I used the MySQL real escape string, which basically escapes any malicious characters you can pretty much think of. So single quotes, double quotes. I believe it escapes like equals or equal signs and everything. So all I had to do was just one extra line of code to change this into something that wouldn't be vulnerable to SQL injections. So now that we know how to locate SQL injections through source code review and a black box review, we're going to have to learn how to actually extract data from it. So earlier I said we can't just see output returned to us. So we're going to have to ask true and false statements to see what's happening on the back end. So here I have an example that shows when we say or 1 equals 1, we're able to load the page properly. But when we say 1 equals 2, the page errors out. So here is the CVE that we had discovered, and I'm throwing it in through burp. So to start, I throw it in through the vulnerable post parameter, otherwise known as pin code, and it has to be URL encoded. So I added the unURL encoded payload at the top. And so when I sent it, I sent in a true statement of single quote or 1 = 1, and then I commented out the rest. And I observed this entire response. And the difference I found is this gave me a 302 redirect. So then looking at a false statement, I sent in the false statement of single quote or 1 = 2. And I saw that this gave me a 200 OK. So now that I know the difference between a true and false statement, I now want to be able to actually ask the database what is true and what is false. So the simplest way to do this is to ask if a value in a certain table is true or false. So here I just did a simple select statement, right? Pretend this is a white box review, so we have access to the database. So I did a select statement on the admin table, and I see that there's one user admin with an MD5 hash password. So to get a single character from the database, we can use substring. So here I'm using a select statement on the user table, and I'm selecting the substring 1, 1. The first value of substring 1 is the position, so it's going to be the very first, and the second one is going to be the amount of characters returned. And then I always include a limit 1 in this case, just because we only want a single instance returned. If we return more than one instance, it can mess up our script at the end because it's getting too much data returned, or the database might not be able to query it correctly. So this is going to be our main form of extracting data, is just a simple select statement using substring, so we can extract one character at a time. So now we need to actually ask it a question. So after we have set up our select statement, we're going to basically ask if the first letter is equal to A. And if it does, we'll notice that the response from the database is going to equal 1, otherwise known as true. Meanwhile, if we ask it a false statement, such as is the first letter from the database, or is the first letter from the username table B, or any other character or letter, it will return false. So now we have a way of actually asking the database true and false questions using substring, so we can ask it one at a time. So now I will insert that payload into the actual vulnerability. So here I insert the select statement, and notice that in this instance, when you're actually inserting it, you have to wrap the entire select statement in brackets, just because you'll pretty much always have to do that, because you're going to want to not error out the existing code, since we're using an or statement. So here I just perform exactly what we saw, where I select the substring of the username 1, 1 from admin, and I ask it if it equals A. And here I see it gives me the same 302 behavior of when I do a 1 = 1, also known as true. So I can confirm that 1 = 1 on the 302 is true, and I can confirm that A is the first letter of the username. And if I follow the redirect, I see that off the 302, I am brought to a new web page. And on that web page, it has the title of course enroll. So with all this information, I now can create a script to brute force this, so I don't have to go through every single character and by myself. So to start, we're going to create a dictionary. So I start by making, Sam and I started by making a pass list and user list. So the pass list, we had access to the database, so we knew it was an MD5 hash. So we only used string.ascii lowercase, and we only did a range of numbers, excuse me, from 1 to 9. And then we passed that into the pass list. And for the user list, we included uppercase characters just in case. So now that we have our password and username list, we're going to start by creating a session. Excuse me. So for this attack, it was a low authenticated user to an admin account. So we actually have to log in first. So we're going to be using the Python request library. And I wanted to point out here that we had to use session equals request.session. So with this module, you can actually pass session cookies and tokens using request.session with a capital S. So when we log in, we're obviously given a PHP sesh ID or some form of session ID cookie. So instead of having to extract that cookie, we're able to pass it manually using request.session. And then we can just log in here. As you can see, data equals F username and F password. So we're passing in the username and password that the user input would like. And then we're going to post it, session.post, since most logins should be a post, with the URL headers equals headers and data equals data. So now we get to the actual chunk of the script. So as you can see at the top, we have print admin username. So we're going to start by targeting the administrator user. So to start, we use a for I in range of 133. 1 to 33 is a little arbitrary. You can do 1 to any number you want. We chose 33 since we kept it consistent with the password list, and MD5 hashes are 32 characters. We then start with a counter equals 0, which will become more obvious later on. And we also define a variable find equals false. So now we're going for J in user list, which if you remember, user list is our dictionary of string ASCII lowercase, ASCII uppercase, and numbers 0 through 9. So now we're going to be iterating 1 through 33. So I is 1 through 33, and J is all of our dictionary attacks. So now we get to where we perform the actual attack. To start, we have URL, which is equal to hostname, and then that is the URL we were using. As we state there, URL may change based on implementation. Headers are the headers we were using. You don't necessarily need them. And data is where we perform the actual attack because it is a post request. So you see here, we're performing the same select substring username, and then we pass in the variable I. So here I is going to start at 1, which if you recall, 1 will be the first character from the database, and we're going to set it equal to J. So every time we get a hit, so what we're doing first is we're iterating through J. So we're going to do select substring username 11 from admin equals 0. And then if that returns false, we're going to do equals 1. And we're going to iterate all the way through that until we get a true statement. And once it hits true, we're going to, username will then change to 2. So we can then extract the second character from the table, which would be D. And then we're going to send this request, and we're going to do counter plus equals 1 every single time it sends, and every single time it finds true. So that way, we can continue to raise I. And then earlier I showed when we followed the 302 redirect, we saw that course enroll was found in the title header. indicating a true statement. So we could have used like if status, if a dot status code equals 302, but we decided to use text. So we're comparing course and role to, we're basically seeing if course and role is there, and if it does, we're basically just going to write J out to the screen, and then we hit the break statement. So we go back to the top. Next, we're using a counter, and we're doing if counter equals length of user list. So if the counter we assigned earlier ends up reading all the way through user list, we're changing find to true, and then we're going to break it. So that way, when we hit the end of the username, we no longer have to, we don't just get stuck in an endless loop. So when we hit admin and we hit the N, and then it goes and checks if there's like, if it's administrator, and it finds there's no more characters because it iterated all the way through user list, it will break and we can move on to our next one. So next, we performed the exact same attack to go after the password hash. So the only difference here is we change the table we're attacking from username to password, and we change the length from user list to pass list, because remember we used slightly different lists just to help with the password list, since we knew it was going to be MD5. So if we run this script, it takes 3 arguments, the host name, the username, and the password. And as you can see, when we run it, it's able to properly extract the admin and password hash, or sorry, the username, admin, and the password hash of an MD5 hash. And we didn't have to manually query the database for all that information. It's a lot easier just to let a script iterate through it. So if you have any questions, please let me know. I would be happy to answer them, or feel free to reach out to me on Twitter or send me an email. Thank you.